Welcome back, business calculators. In this video, in this screencast, we take a look at an economic example of related rates. How can this actually pop up in your world? And so what we're going to do is we're going to examine some company that we're running, and we have a cost function, and this cost function is 0.3 x squared plus 8,000, where X is the number of units that we make in a month. This is the number of units that we make in a month. And we're going to assume that the production level increases at the rate of 10 units per month. And we want to find the rate at which cost changes when the number of units is 60. When the number of units is 60. So when we say increases at 10 units per month, X is a number of units. So this is how that number is changing. This is dx dt. This is the rate of change of the number of units with respect to time. Cost isn't measured in time, X isn't measured in time, but we're asked for the rate at which cost changes. We're asked to find the rate of change of cost with respect to time when X is 60. So how do we do that? Well, we take the derivatives on both sides with respect to time. We take the derivative of this with respect to time. We take the derivative of this with respect to time. Remember, the 2 comes down in front, the power decreases by 1, but that's an x, not a t. So we have to multiply by dx dt to complete the chain. This is the chain rule come back to rear its ugly head. So dc dt is the thing we're interested in. The production level is 60 units a month, and dx dt is 10 units a month, and this happens to be $360 per month. It's a rate of change of cost with respect to time, so its units are in unit of cost per unit of time, dollars per month. Our cost is increasing by $360 a month at this moment in time. It's increasing by different amounts at different moments in time, but at this moment in time, it's increasing at $360 per month. But let's go on. Right? Let's go on. Let's consider revenue. Let's suppose that the cost is connected to revenue by the following equation. C is r squared over 200,000 plus 6,000. Let's just imagine that we have found a relationship between the cost of our product and the revenue it generates, and it's related in this way. Let's find dr dt when x is 60. Well, again, we're looking for dr dt, that's time. Time's not here, time's not here, so we introduce time into the scenario by taking the derivative of the left side with respect to time, and then the derivative of the right side with respect to time. Derivative of 6,000 is easy, that's 0. Derivative over here, we're just going to take the derivative of the r squared and put it over the 200,000. That's more than fair. And then r is not time, so the chain rule says we have to multiply by its derivative with respect to time. So this is the thing we're looking for, which means we must know dc dt, and we do. We had it on the last slide. 2 over 200,000 is going to be pretty straightforward. R. What's R when X is 60? Well, we'd go back here to figure out what C is when X is 60, and you can do that. You can put a 60 there and figure out what all this is. Turns out that the C is 9,080. And we could do some algebra off to the side that says that 9,080 is r squared over 200,000 plus 6,000. We could solve for r. It's not terribly difficult. We get that r is about $24,819. And we can put that $24,819 right here. And when we solve for dr dt, when we move these things out of the way, dr dt happens to be $1,450.48 approximately. What does that mean? That means that at the moment when production has increased to the point of 60 units a month, our revenue is increasing at $1,450 a month. That's what that means. Well, I'll consider one more thing before our time runs out. Staying on that theme, how is profit changing at the time when X is 60? Because sure, we've got revenue and sure, we've got cost, but what's the deal with profit? And you and I both know that profit is the revenue minus the cost. That's not measured in terms of time. That's not measured in terms of time. That's not measured in terms of time. So if we're going to bring time into the equation, we take the derivative here with respect to time. We take the derivative here with respect to time. We take the derivative here with respect to time. This is the thing we're looking for. We figured out dr dt on the last slide. We figured out this 2 slides ago. And so profit is increasing at $1,090.48 per month at that time. So what is the big takeaway for us? If we're looking at equations that don't have time in them, but we have to find their rates of change at particular times, we do that by taking derivatives with respect to time using the chain rule, and we make appropriate substitutions. I hope that's clear to you. We'll be able to talk about it when we gather. We'll see you soon.